So we want to take a look at calculating the slope of a line from a graph. So what we're going to do is we're just going to simply be counting um, units on our coordinate plane here that are related to the slope of our line. So we're going to do this by starting by finding 2 points on the line. And you want these to be 2 points that if you're looking at the grid of the line, the points should be right on the kind of intersection of the grid line. So you want to pick points that have integer values, not points that might have decimal values. Okay, so all we're going to do is we're going to count up or down, which is our rise, and then we're going to count left or right for our run. All right, and we're going to go from one point to the other, and we're going to do this just like we read a book, right? So from left to right, all right? Leftmost point to rightmost point. So we want to remember our slope is always the vertical change, right? That's our y, over the horizontal change, that's our x. So we often refer to this as our rise over our run, okay? So we'll take a look at the special cases after we come to those graphs, but let's just take a look at a normal kind of slanted line first. So when we're taking a look at this, we want to just go ahead and you want to almost imagine making like a triangle between the 2 points, right? And then you want to count. So we go from the left point to the right point. So we rose 1, 2, 3. We ran 1. All right, and then we want to write that as our slope. So our slope is always our rise over our run. Our rise was 3, our run was 1, and we always want to reduce if we can. So 3 divided by 1 is just 3. So let's keep going. You can draw your little triangle. It helps to keep us organized. Now, this time, we're not running up, we're running down. When we think about going down, that's a negative movement for our slope, right? So we're going to go down 2 units, and then we're going to go right 4 units, all right? So that means our slope, our rise over our run is -2 over 4, which when we reduce it, we get -1/2. All right, let's keep going. Make our little triangle here. We're going to rise up 2, so that's positive. We're going to run right 3. Right is always positive, left is always negative, okay? So our slope is going to be 2 over 3. Just always check if you can reduce it. In this case, we cannot. All right, last one we're going to do before we talk about our special cases. So you can draw your triangle, sketch your little triangle here. All right, so we're going to rise, well, fall. 1, 2, 3, 4, 5, 6, 7. So down 7, that's going to be a -7. And then 1, 2, 3, 4, 5, 6, 7 to the right. All right, so our slope is going to be -7 over 7, which reduces to a -1. All right, now let's talk about these next 2 lines. So we have first a vertical line, and second we have a horizontal line. I'm going to do these the same way I did all the other graphs, and then we're going to talk about kind of the pattern that's going to happen with these lines. So if I look at these 2 points here for example number 5, I can't draw a triangle, right? If I connect these points, they just connect just with one line, right between them, one vertical line. So let's just keep with the pattern of what we've been doing and look at our slope. So our slope is going to be our rise, 1, 2, 3, 4, 5, 6, 7, 7, over our run. Well, we didn't go left or right at all to get from one point to the other. So we had no run here, only rise. Now, we can't really divide things by 0, right? So whenever we're dividing by 0, we can't get an actual value. So we just call this undefined. This is an undefined slope. we can't give it a numerical value. It is perfectly vertical, straight up and down, and it is our undefined slope because we have no run, no left or right movement, okay? So all of our vertical lines, our slope is gonna be undefined. Doesn't matter where on the coordinate plane it is, if it's vertical, it'll always have no run, so it'll always be an undefined slope. Let's look at our horizontal line and see what happens here. So this time when I connect my 2 points, I get just a little horizontal segment there. So now if I count my rise over my run, well, I have no rise. To get from one point to the other, I didn't go up or down at all. So I'm just gonna say my rise is 0. My run is 1, 2, 3, 4, 5. All right, well, anything divided by 0 is just 0. So our slope here is perfectly flat, it's a perfectly horizontal line. Our slope is 0. So this is going to be true for any horizontal line. Our slope is always going to be 0 because we'll never have any rise. No rise on a horizontal line, just run. So those are kind of our two special cases that are always going to be having the same slope no matter where their position is on our coordinate plane.